There we are. So if you look back to the early days of CAA, and up on the right is the in fact this may be even volume, the first ever CAA conference proceedings, which had all of 20, 30 pages, and was a little booklet about A5 size, not much bigger. Um, CAA has really been a fantastic guide to what has been happening in archaeology, in quantitative methods in archaeology, from the earliest conferences, which were held in the basement at Birmingham Computer Centre, and where sort of people carried in their boxes and they plugged things in and so on, to what it is today. Um, so if you look at those early years, the 1970s, it was very much about things, well, a lot about statistics, factor and cluster analysis, things with simple inventories, how you to structure a file with data from analyzing hand axes or things like that. And really, the early microcomputer databases came in with DBase2, Mazda, which is either Arkansas or Arizona. I can't remember. Site register, etc. Those really started in the 1980s, and I worked on a database management system called Minarch from 1980 to 1987. Some of you may have come across it. Um, uh, but one of the interesting things that think you see in that evolution of software is we now do a lot more with a lot less. So, in other words, where previously you had to program everything, every little detail, now you have a checkbox, and a checkbox. There's a whole lot of stuff behind the scenes that would have in the past been lots of different steps. For instance, you might put a check that says you want a field to repeat. Well, you'd have had to create individual tables. You'd have to have looked at the cardinality of the connections, etc., etc. Now it's just a checkbox, and that's basically what Hurist, my system I've been working on 20 years about, is building something which is easy for people to use, which hides all the complexity of what's going on behind the scenes. And that's a general trend in software. If you look at the difference between ArcInfo back in the 1980s, where people reckoned it took a really competent person 3 months to learn it, and then around came MapInfo, and it was pretty easy to use, and you could get up to speed with it in a matter of a couple of days. And of course, GIS, QGIS have evolved to become much easier to use. So that's the general trend in software. And of course, AI is kind of the next step past that. So we're getting further and further from our data. We have less visibility of what's actually happening. And that's both good and bad thing, because really knowing what's happening underneath the hood really isn't very important to us if we're researchers in any field in the humanities, archaeology or elsewhere. On the other hand, we do need to know what's going on, and we put a lot of trust in developers actually developing something that does what it's meant to do, and we don't really have much visibility ourselves on what's actually happening. And again, that's something which is becoming more and more the case with AI. We have no idea what's going inside, and even the people who program have no idea what's going on inside it. That's one of the aspects of research in the field, is to try and understand what the thinking process behind AI is. Uh, on the other hand, coding has become much more complex. It hasn't become simple, although one can still write quick scripts, which are easy to build because you have libraries that do things and you just sort of call them. Um, Writing serious full stack programs has really become a very complicated matter. So this the trick bo- the checkbox, which does lots of things behind the scenes, you may not have to deal with all the things that are happening behind the scenes, but you have to deal with a whole other, such as what all sorts of different options, different approaches you might take, connectivity between an application and the browser that's using it, things to do with data formats, sort of event handling, security issues of being on the web, all those sorts of things. It's really become a very complex and specialized activity. So while we, as shall we say, as practitioners of archaeology or another humanities discipline, can do simple scripting and so forth, most people are never going to get into really getting down to the bottom of things. So we're very dependent on programmers and the technology that we use. So if you moving forwards a little into the late 1970s and nearly 1980s, there was this wonderful idea that data banks were going to do everything. So all the data about archaeology, particularly in archaeology, I don't know about other disciplines. Um, there'd be a database, and you'd simply ask it the questions, and it would give you all the answers to your questions. Today, we'd call that a data lake. I don't know of any data lakes in archaeology, really, but it runs into a lot of problems. First of all, is all the ownership questions and the questions of things like security of data, particularly site locations. It runs into standards because as archaeologists, we love having lots of standards. Because we don't really quite understand what was going on in the past, um, we find it very hard to code it in a way that we can all agree on. And because everybody has such different interests, such different understanding of the past, of the objects of the past. So standards are difficult. Coverage is difficult because uh, our data comes first of all the taphonomy of how we got our data in the first place, and secondly the randomness or the haphazardness of what we collect based on where there are development projects or where people are doing an excavation, research excavation, and so forth. And finally, technical constraints that we are relatively short of money and being able to hire technical expertise. So we are often constrained to doing things ourselves. And therefore, the technology to build a data lake is really beyond what we actually have available, even if we had all the data available to do it. And what I see, in fact, is that the approach really has changed, and no longer people are thinking. Well, in fact, by the mid '80s, nobody was thinking about the possibility of data banks really. But we're now working on much more distributed data, indexing and harvesting data, running searches across uh, either harvested data or across indexed data, and all sorts of work, huge amounts of work, ontologies and semantics, paradata, metadata, um, reproducibility of research, protocols, and so forth, and all around the FAIR principles. We still have the problem of findable, actually, and this applies not just to archaeological data, but it applies to even to what sort of tools are available and how to use them. Nobody has yet come up with a really good single access point to find out about everything that's available. Lots of different departments have created their own short lists, often missing a lot. There was the dirt directory, which even though it was a one central point, many people didn't know about it, and it was never much more than a list with the description that the developers had provided. It didn't really give the 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 knowledge to understand. If you didn't already understand what you were looking at, it didn't give you the knowledge to really see and decide what you wanted. It was a useful guide to what was available. That was about all. And of course, linked up data, which is been the buzzword for 10 years or so, a means of linking together all these disparate sources, but with still all the same problems of uh, standards and coverage and technical constraints and so on. Um, so problems of coverage really is the one that remains, and that's led to a lot of specialized databases for things like site registers, recording dates, or particular categories of artifact, which really are things that could be standardized across an area and be useful in their own right. A general database, uh, to my knowledge, of archaeology, even for a biggish region, that does not exist. So AI offers obviously many advantages. They're fantastic for coding. They're fantastic for bug detection, and for reviewing and revising code. We've been using AI a lot for Hurist to clean up our code, to create a lot of new documentation. For instance, this is a fantastic system called DeepWiki. We fed it Hurist, which is about a quarter of a million lines of code, and said, "How does it work?" and it produced a complete documentation. I sent it off to Artem, my chief programmer, and he just wrote back with one word. He said, "Wow," and it's pretty accurate. It gives a pretty good idea of how this thing works. And all we did was just code and said, "Look at it." Um, so there's tools like this which are coming out, which is just amazing. I use it quite a lot to write scripts for the. I was working last week on a project where we recovering database, which is emeritus professor's life work on the Shahnamar, has 20,000 images. The images are all identified by hash codes, which was actually fantastic. The database contains lots of hash codes, and there's a whole lot of images, and the two aren't connected together. I was able to write scripts that would just go through and find. We've done a lot of them, but find all the missing ones and tell me where they were, and give me a file that I then use to move things into where I needed it to be. Um, it's like having an exoskeleton to climb hills. It's or if somebody for going skiing. Apparently, people are now skiing around with exoskeletons on. It's a kind of exoskeleton for not very good programmers like myself. I mean, an old hat programmer. I tinker with the code that's been done, but I could never write from scratch. Although maybe I could, in fact, write from scratch. So it's been very good for improving program documentation. It's been good for end user documentation. We're currently rewriting the Heuris documentation, and we've got basically I broke everything that we had up into chapters, and I then asked ChatGPT to make a summary of each chapter and stuck that on top of each chapter. And we've got a group of people who are working on it, and they've been looking at the summaries of the chapters and looking at what's in the text. And one of them said, "Well, I reorganized the text before looking at the summary, and in fact, the summary had done exactly the same reorganization that I'd done, but the summary took 2 weeks, and they spent a day on it." So very, very useful for all sorts of documentation. And what I'm aiming at doing is, in fact, providing a chatbot that can ask questions, which will be trained with a RAG, and I can't remember what RAG stands for, a RAG, to with all the documentation that we have, so that we'll be able to hopefully answer a lot of the simpler questions, and maybe one day all the questions. Who knows? Um, uh, Obviously, they're very good for things like detecting patterns in data and providing hypotheses and summaries, but one doesn't really know how they do it. So uh, they're a useful tool in that sense, but you can't really rely on what they do. And they can carry out complex and repetitive processing tasks on virtual machines. So that's really only in the last year, I suppose. So that in fact you can set them to program them to go through for you. And that's becoming the speed with which this is developing is just astounding. Um, I think they'll soon be able to build effective data models. So you can say, here's my data, this is what I'm dealing with, this I want to find out, and so forth. And it will be able to tell you how to program, how to set that up in Heuris or another system, or indeed it will be able to do it itself because it can now access the web and you can just give it access to do that. Um, my attempts to do that so far have it's basically given me a very good data model in an SQL database. When I told it that that wasn't quite the way you did it, and that it used, for instance, a pointer field between records to them, it invented a field type that didn't exist. Well, it was quite a good idea, but it wasn't actually. It was really it obviously understood access, and it didn't actually know much about Heuris at the time. But that's something that will change. Um, uh, so that you could indeed, pretty soon, actually, you could say, here's my data, here's a whole lot of data in whatever format you want. Have a look through this, work out what it's all about, build me a data model, create a database, um, and and set me up an interface to manage it and create me a website from it that looks a bit like this. And it will be able to do it, and it'll be able to do it probably fairly soon. The problem, of course, becomes bespoke code, which has been a problem since the dot. And really, that's the reason heuristics exist, is to avoid bespoke code, and therefore the long-term maintenance that um, goes with such bespoke code. Although, of course, one could say, well, you'll be able to use AI to update the code and so forth, and that's probably true. That is coming along, but in the end, um, generic systems such as Heuris and Omica and others were really designed to standardize the way data is stored and the way data is processed in a way that is uh, understandable and reproducible. So, uh, will AI become part of Heuris? Well, it's really um, at the moment, at least, it's evolving too fast. It's too unstable. What's there now in 6 months won't be there. It'll be all different. And also, it doesn't produce the same results. In fact, it's programmed not to produce the same every time. If you ask exactly the same question, you'll get different answers. So we're really looking for something which is much more reproducible. Also, tends to run into the problem as soon as you start to get the full capabilities, you have to start paying, and that's true of a lot of different things. So we're certainly with yours trying to write very much in the open source field. Uh, and particularly as we still need to generate money from this the open source approach because I have to pay my developers. Um, but I can certainly see that, as with many other tools that we use with Heuris, like R and QGIS and so forth, we will be looking at generating outputs that can be passed over to a specific sort of analysis. We do use it quite a bit in translation. We currently use the free license in DeepL. So you can have a text field and you click on the text field on the translation that says what language, and it gives you a translation of the text field and inserts it. Um, uh, so interfacing with that sort of thing is quite easy. You just basically there, you pass it some text, you tell it what language, and get a translation. It's easy to configure. You can use Google Translate Live on the existing interface, but the problem there, particularly I do a lot with French, is French is a more verbose language than English, and so you can see that things tend to wrap where you don't really want them to wrap. And also, I've to kind of carefully refined and thought, what word could I use here to make it, quickly. It's very important when designing interfaces that you use as few words as possible so they become symbols that you recognize. You immediately land on entities. Okay, it's entité. You land on save filters. That one's okay. But you land on save filter for reuse. Enregistrer le filtre pour le réutiliser. It's wording. It's short and clear that becomes that you almost don't read. It's almost like a symbol. We do have symbols, but actually, I don't think anybody probably. I don't use them anyway. Uh, but I just kind of know where things are, and it's a pattern that I recognize, but it's short and concise. So automatic translation doesn't tend to work very well for that, although that can probably be refined. And it sometimes does do errors like close in on a button, and it translated as near, proche in French. It doesn't necessarily have the context. So is AI the answer? So it's a bit like the data banks. You ask a question on anything, and AI will give an answer. But AI, recent work on AI has sort of suddenly realized that the problem with AI and its fantasies, uh, its hallucinations, is that it is programmed to please, and it's programmed to please by giving an answer. And if it doesn't know, it'll invent one. Um, uh, Even if it produces an answer, where did the knowledge come from? You don't know what its background is. It's good at searching the web, and it can assemble. It's very useful for answering things like ChatGPT for answering questions about whatever you're interested in. There is this problem of hallucinations, and you don't know how the answer was generated. If it's going off and doing a web search and pulling together some information out of general interest, it doesn't really matter. If you're trying to analyze your data, it does. So we have no control really of what's happening. We have no confidence. It's a bit like asking your research assistant who you don't actually know or how they think. In fact, they just walked in the door and say, "You're my research assistant. Go off and find me out and work out the statistics on my data set." You have no idea what you're getting back really. It may look good, but that doesn't mean it is good. So, even more importantly, we really can't entrust our data to AI's black box. Uh, Everything's about rapid evolution, commercial drivers. It's things are changing very fast. You don't know whether the system that you're using today will be there tomorrow, or whether you have to pay a lot for it. There's no sense of sustainability, and that includes both the environmental impact, as we know, is enormous, but also in terms of permanence. You find that what you did 6 months ago isn't there anymore. For various reasons. So what we really need is open source formats. We need good paradata and metadata. We need semantic standards. We need stable public servers, which need institutional funding that we can rely on. Of course, in the modern day, we can't even be sure of that, but that's not a problem we can really solve. And we need control over how our data are modeled, how they're stored, where they are, how they're backed up, what we can do with them. And we want to know that the data will not have been modified because the AI decided it wasn't as good and they could do a better job or something like that. And we need transparency in data handling. And we need interfaces which allow us easy, clear, understandable, predictable access to the data, which can include interfaces which allow machines to talk to it and allow AI and other systems, as I mentioned, aren't you just access the data. So I'd like to misquote. I love the days of the numerator numbered. So I want to misquote is the days of the database are not numbered. AI isn't suitable for well-structured databases and transparent analysis. You shouldn't trust AI with your data, but that doesn't mean you shouldn't use it. There's plenty of uses, as I've pointed out. So if there are some questions or comments, I'd very much like to hear it.